Good morning, everyone. This is Mr. Extra, your math teacher who loves you a lot. And let me tell you guys, I miss you a lot, and I hope that we will be able to see each other very soon. Okay, eighth graders, I hope that you're ready to start our journey in math. Remember last time I posted videos about decimals, conversion from repeating and not repeating decimals to fraction, and from fraction to decimals, repeating and non-repeating decimals. And today we will talk about the sets of numbers, and we are going to classify the sets of numbers. Okay, let's start. Okay, classify sets of numbers. Before we classify the sets of numbers, we need to answer this question. What is a set? Okay, I'm letting you think about it. You can pause the video, try to find an answer, and we will discuss. Okay, yep. Okay, guys, whenever you hear the word set, a set is a collection of objects. Objects. This is it. For instance, if you have books for 5 books, you can say that you have a collection of 5 books. And let's say that at home you have Naruto's books like the volume 1, volume 2, and volume 3. And let's say that you have another collection of manga which is Dragon Balls. You can have the Dragon Ball volume 1, volume 2, volume 5, volume 3, 4, 5, and 6. You can say, okay, I have a set of Naruto books. This is a set. In your set, you have only 5 volumes. And you can say, okay, I have a set of Dragon Ball's books, the Dragon Ball books, then which means that in your collection you may have 10 volumes. Okay, a set is a collection of objects. If you don't want to say a collection of objects, you can say a group of objects. And this is the same thing when we are at school, for instance, for you eighth graders, we can say when I take everyone, for instance, I take Matthias, Joachim, Gaetan, Luigi, Denslin, Chris Etienne, and guys, I put you together. And when you are grouping together, we can say you are the set of eighth graders. That means each one of you is a member of the eighth grade. Then I hope that you understand. A set is a collection of objects, or if you don't want to say a collection, you can say a group of objects. Then each object in the set is called an element or a member of the set. For instance, when I can say that Joachim is a member of the eighth grade. The eighth grade is the set. We can say that Joachim is a member of the set of the eighth grade. We can say Matthias is a member. Luigi is a member. Denslin is a member. We can say Chris is a member. Okay. Gaetan is a member. Okay. Then we write the element of a set in braces. This is what we do, guys. For instance, okay, if you have a collection of Naruto's books, you have the volume 1, 2, and 3, and you want to write the element of your set, then you are going to put every single one element between or in braces. For instance, I can say, okay, this is my brace. You have the volume 1, volume 2, volume 3, volume 4, and volume 5. And I close the brace. You see, then this is a set. Whenever you want to write the element of the elements. Yes, the elements of a set, you put them in or between braces. This is what we do. Okay, remember in seventh grade, we learned that the whole numbers consists of the numbers. There is no S here, guys, okay? No S. I am removing it. Okay, we learned that the whole numbers consist of the numbers 0. That means the set of whole numbers starts from 0 and goes indefinitely. You see, I have 0, 1, 2, 3, 4, 5, where the numbers continue forever in this way because the dot 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 means that the numbers continue forever in this way. Okay? The whole numbers, whenever we are talking about the set of whole numbers, the whole numbers are all of the positive numbers included 0. This is what we call whole numbers. And remember, in sixth and seventh grades, you used the whole numbers a lot. And we can write the set of whole numbers like this. We have braces, 0, 1, 2, 3, 4, 5. That means that it continues forever in this way. That's when it goes all the way. Okay? Then we say, and we close the braces, and we say that this is the set of whole numbers, 0 and the positive numbers. Then, if we take out the 0, for instance, if we take out the 0 of the set of whole numbers, we get the set of natural numbers, which is this. We open the brace, we have 1, 2, 3, 4, 5. That means that it continues forever in this way. And we close the braces, we say this one is the set of natural numbers. Why? Because 0 is excluded. We don't have 0, we start from 1 to forever. But in the with the whole numbers, we start from 0. The second one is the set of natural numbers because we don't have 0, but we have all of the positive numbers. Remember, guys, only the positive numbers. And we call the first one the set of whole numbers because we have 0 and the positive numbers. No negative numbers, only positive numbers. Then the first one is the set of whole numbers because we have 0, 1, 2, and forever. And the second one is the set of natural numbers because we have 1, not 0, except a 0, and we go 2, 3, 4, 5, and forever. And let me tell you guys, we call these numbers natural numbers because when you were learning to count, we started to count from 1. Naturally, this is what we do. We start counting from 1. And they have another name. The set of natural numbers have another name. We call them the counting numbers. Why? Sometimes the natural numbers are also referred to as the counting numbers because when we learn to count, we start with 1. This is why we call them the natural numbers because this is what we naturally do when we are counting. We don't start with 0, we start with 1. Okay? Okay. We we have another set of numbers. The set of integers. What does that mean? The integers includes include the negative numbers, 0, and the positive numbers. Whenever you have negative numbers, 0, and positive numbers, then you have the set of integers. You see, I have my braces open and my braces closed. Then between my braces, I have the negative numbers, I have 0, and I have the positive numbers. When you put the negative numbers, 0, and the positive numbers together, you have the set of integers. On a number line, Positive numbers, you see positive numbers are to the right of zeros. This is it. This is 0. You see I have 0 here, and my positive numbers are placed to the right of 0. This is the right of 0. I put an R for right. This is the right of 0. Then to the right of 0, we have the positive numbers 1, 2, 3, 4, 5. That means we continue forever to the right of 0. And negative numbers are to the left of 0. This is the left of 0. Let me put a big L. You see, left of 0. And then our negative numbers starts from -1, -2, -3, and goes all the way to the left of 0. Okay? And remember that 0 is neither positive or negative. 0 is just 0. Okay? It isn't negative, it isn't positive. Never put a negative sign or positive sign in front of 0 because it is not. It is neutral. Okay, guys? Remember. Okay. Given the set of numbers, let's do a little exercise. Okay? Given the set of numbers, remember a set is made of two braces, and we place the elements. The elements of a set are placed in a braces. This is why I have braces. Whenever you see this, this is called the set of numbers: 4, -7, 0, 3/4, -6, 10, -3, 0.5. Okay, guys? Okay, given the set of numbers 4, -7, 0, 3/4, -6, 10, -3, 0.5, list the whole numbers. They are asking us to list the whole numbers. That means in that set we are going to identify the whole numbers, natural numbers, and integers. Let's start with the whole numbers. Solution. Whole numbers. Remember that the set of whole numbers is made of what? 0 and all of the positive numbers. Then we have 0, we have 4, and we have 10. And these are whole numbers, or whole numbers. This is it. And what about the natural numbers? Okay, let me change the color of the pen. For the natural numbers, remember natural numbers doesn't include 0. That means for the natural numbers, we only have the positive numbers. We have 4 and 10. This is it. Natural numbers 4, 10. Then if you wanted to represent this, okay, the set of positive numbers in this list, in the list above, you would say, okay, the whole numbers are 0, 4, and 10. This is it. And if you wanted to represent the natural numbers, you would say 4 and 10. This is it, guys. Okay, good. Now, and for the integers, let's identify the integers, okay? Uh-huh. Okay, or blue. Remember that that the integers are the negative numbers, 0, and positive numbers. Then we have -7 is an integer, -6 is an integer, -3 is an integer, 0 is an integer, 4 is an integer, and 10 is an integer, which gave us this. We have integers -7, -6, -3, 0, 4, and 10. These are our integers. I hope you understand, guys. Okay. Remember that the whole numbers are 0, 1, 2, 3, 4, 5, and we continue forever because they are all positive numbers. And the natural numbers doesn't include zero. Natural numbers says, okay, we discard a zero. Then they are one, two, three, four, five, and continue all the way, okay, to the right of zero because they are positive. And the integers are all of the negative numbers, zero and positive numbers. Now, if you notice in this set of numbers, 3/4 and 0.5 did not belong to any of these sets. What does that mean? 3/4 isn't a whole number. 0.5 isn't a whole number. 3/4 isn't a natural number, and 0.5 isn't a natural number. 3/4 isn't an integer, and 0.5 is not an integer. Why? Because that is the whole numbers. You see, you need to keep this. The whole numbers, natural numbers, and integers do not contain any fractional parts. Whenever you have decimal and fraction, they are not whole numbers, neither natural numbers nor integers. Okay? They are not. Then what are they? They are what we called rational numbers. This is how we call them, rational numbers. But why? Let's see why. Rational numbers. Definition. A rational numbers is any number of the form P over Q when P and Q are integers and Q is different than zero or Q is not equal to zero. Let me explain, guys. A rational numbers is a fraction, a division, a quotient. Why? A fraction is a division. Remember, a fraction is a quotient. So, whenever you have something like 3/4, this is a rational number. Whenever you have something like um 2/5, this is a rational number. Why? Because it is expressed under the form of a fraction. If you don't want to say a fraction, you can say a quotient. If you don't want to say a quotient, you can say a division. Whenever you have a form like P over Q, which in P is an integer, what does that mean? P and Q are integers. It only means that the numerator can be a negative or positive number and the denominator can be a negative or positive number. Like this, you can have -1/2. This one is a rational number. And also, Q should not be equal to zero, or Q does not equal to zero. Remember, if you have something like this isn't a rational number. Okay, you can't have zero as a denominator. This is why they says that Q does not equal zero. You see this symbol? Sorry guys, this symbol means does not equal to, or if you don't want to say does not equal to, you can say is different than. Q should be different than zero. Q can be any number except a zero. Okay, then which leads us to the definition. A rational number is any number that can be written as a fraction. If we don't want to say a fraction, we can say as a quotient. Okay? Where the numerator and the denominator are integers. What does that mean? Remember the set of integers. The set of integers says that we have all of the negative numbers, 0, and all of the positive numbers. And this is what it means. It means that the numerator and the denominator can be any number, positive or negative, but the denominator can't be 0. But you may ask the question, what about the numerator? If I have 0 over 2, that means 0 half. Yes, this is a rational number. Why? Because it is written under the form of a fraction and the denominator does not equal 0, but the numerator equals 0. This is a rational number, okay? Only the denominator can't be equal to 0. You see, only the denominator does not equal to 0, but the numerator can equal, okay, can equal to 0 or does equal 0 to 0. Okay. Then the number 3/4 is rational. Why? Because it is a fraction in which the numerator and the denominator are integers, because 3 and 4, they are integers because they are positive numbers, and the denominator does not equal 0. You see, 4 is different than 0. Then we say this is a rational number. Okay, the number 0.5 is rational because it can be written as the fraction 5/10. You remember, whenever you have a decimal number like 0.5, if you want to represent it as a fraction, you take the number, the digit after the decimal point. You see the decimal point, the digit after the decimal point is the numerator. Then you count, how many digits do I have after zero, after the decimal point? We have only one digit. Then since we have one digit, it is 10. The denominator is 10. If we had two digits, it would be 100. And if we had three digits after the decimal point, it would be 1000. Then this is it. Or we say 1/2. Why 1/2? Because if we reduce it by 5, because we can divide the numerator by 5, and we can also divide the denominator by 5. You remember, guys? 7th grade. Then 5 divided by 5, 1, and 5 divided by 10, this is 2. This is 2, guys. This is where we have the 1/2, okay? The number 0.5 is rational because it can be written as a fraction and as the fraction 5/10 or 1/2. Explain why each of the following numbers is a rational. 7, 0.8, -5, 6 and 1/2, 0.3, and notice the bar. Okay, the bar, it means that 3 is a repeating decimal. What does that mean? It only means that we have 0.3, 3, 3, and 3 goes indefinitely. It will never stop. This is what we call a repeating decimal. Remember, okay, the videos from last time. Okay, it was on Khan Academy. Okay, solution. 7 is a rational number. Why? The reason is that 7 can be written as 7/1. Any number, remember, we never put 1 as a denominator. Why? Because every single number has 1 as a denominator. For instance, if you have 4, 4 is equal to this. 4, you see, this is it. If you have a 3, 3 is the same thing. Sorry, guys. Okay, 3 is the same thing as, you see, 3/1. Then since we have 7, seven as a 1 there. This is why 7 is a rational number, because 7 can be written as 7 over 1. And remember, every number has 1 as denominator. We never put it because we don't write 1 as denominator. Okay, guys? Whatever the number has 1 as a denominator. Then since 7 over 1 is a fraction, and 7 can be written as 7 over 1, we say that 7 is a rational number. 0.8, remember, 8, we take the number after the digit, after the decimal point is the numerator, and we count. We have one digit after the decimal point, then we put 10. Then we say 0.8 is a rational number because it can be written as 8/10. And what about -5? Remember what I said. Every single number has 1 as denominator. Then -5 is a rational number because -5 can be written as -5 over 1. This is it. And what about 6 and 1/4? This is a mixed number. Then remember, a mixed number should be converted. We can convert a mixed number into an improper fraction. To convert a mixed number into an improper fraction, what do? We multiply the denominator by the whole number, which is 6. We say 4 multiplied by 6, which is 24. 24 plus 1, I mean plus the numerator, is 25 a fourth. Whenever you want to know if a mixed number is a rational number, you should convert it into an improper fraction. How do we do it? We multiply the denominator by the whole number, 4 multiplied by 6, which is 24, and we add the numerator to the product. Then we say 24 plus 1, which is 25. 25 fourth is a fraction. Then we say that 6 and 1/4 is a rational number. And what about our 0.3? And remember, this one isn't part of it, okay? 0.3, and we have the bar. This is what we call a repeating decimal. Then, since 1/3, when we divide 1 by 3, I will show you guys. I divide 1 by 3. How many times do I have 3 is in 1? 0 times. Then I put a 0 here. I put a dot and I put a 0. Then how many times do I have 3 is in 10? 3 times. 3 times 3, 9. And then I say 10 minus 9, 1. A 0 again. 3 again. 3 times 3, 9. 9. Notice, guys, if I continue, I will have a sequence of 3. It will never stop. Then we say that, okay, 0.3333, okay, can be written as 1/3. This is why it is a rational number, because 1/3 is a fraction. Okay, let's continue. To summarize, okay, the set of rational numbers includes integers, whole numbers, and natural numbers. An integer is a rational number, a whole number is a rational number, and a natural number is a rational number. Remember that, guys. Integers, whole numbers, and natural numbers, they are also rational numbers. This is what it means. That means 1 is a rational number, 0 is a rational number, 10 is a rational number, -5 is a rational number, -6 is a rational number, and -100 is a rational number. Okay, guys? And also, repeating decimals are not rational numbers. For instance, 0.5, and the bar means 5 is being repeated. Okay, then this is a rational number. 0 or the 12, and I put the bar above 12. This is a rational number because 12 is repeated. That means when we put it like this only means that we have 12, 12, 12, and it goes all the way. And also, terminating decimals are rational numbers. For instance, when we say terminating decimals like 0.4, 1.5, because it is terminated because the decimal part doesn't repeat itself. Okay, we only have it like 5, no more. Okay, all of these are rational numbers. Okay, guys, take the time to read the notes. If you if you need to pause the video and to read the notes or to copy them, you need to do so. Also, if you want to review, just you know start the video over. And we say fractions and mixed numbers are also rational numbers. Remember, whatever the fraction, whatever the mixed numbers, it is a rational number. Okay, now let's talk about irrational numbers. An irrational number. What is the set of Okay, the set of numbers that cannot be written as the quotient of two integers. What does that mean? If you can't write a number as a fraction, and that then we say that this number is an irrational number. Okay, the set of numbers that cannot be written as the quotient, I mean as a fraction, is called the set of irrational numbers. Written in decimal form, you can only write them in decimal form. An irrational number is non-repeating, non-terminating decimal. What does that mean? If we have something like 4, 1, for instance, 5, 6, 5, 3, and we say that, it goes all the way. If you don't see the bar, that means nothing is being repeated. The sequence, the as long as you're moving away, there will be no pattern. Okay, look, I have 1, 4, 6, 5, 3, and they don't look the same. This is a non-repeating or non-terminating decimal. Then we say this one is an irrational numbers because you can't represent it as a quotient or as a fraction. Okay, guys? Explain why each of the following numbers is irrational. For instance, this one, 0 point or 0.827136, and that means there is more. Okay, there are more digits. And p, let's see, p is French. Okay, sorry, pi. Let's see the solution. You see, we have 827,136. It isn't a repeating decimal because nothing is being repeated. It isn't a terminating decimal neither. Why? Because we have the dot means that it never stops. It continues all the way. Then since this number is a non-repeating and non-terminating decimal, we say that this is an irrational number. And what about pi? We say that pi is substantially equals to, you see this symbol only means substantially equals to. What does that mean? That means that in French we say that est sensiblement égal à. It means that it isn't equals to that number, but it is quite close to it. This is what it means. It is quite close to it. You see that this is a 3.14159,265 and dot. Now, you see the decimal part doesn't repeat itself. Not only that, it doesn't stop. That means that it never stops. Then we say this is a non-repeating and non-terminating decimal. Then we say pi is an irrational number. Okay, guys, that was all for today. I hope you enjoy yourself and you understand everything. If you don't understand something, um, play the video again or go to the part that you don't understand. And you can also contact me via email or my phone. You can call me, then I will explain everything to you, okay? And I will post the homework for you. And bye bye. See you next time.